Welcome back to Seriously Funny. I'm your host, Mashnor Kabir, and I have been traumatized by research. When this episode comes out, I will have completed my first 3 exams of this first semester from chemistry, science, technology, and society, as well as linear algebra. I am obviously extremely excited about this. Not really. Along with that, instead of studying for my 3 exams, I've opted to spend the past day and a half studying sleep for a future podcast episode. At the time that I was writing this show notes, I was 30 sources in. I think I'm about 45 sources in now, and probably 3/5 through what I want to get through. It's a bit of a doozy. And no spoiler alerts, but I do want to say please sleep for 8 hours. You'll find out why if you stay tuned. Anyways, as that episode gets researched, I wanted to discuss some simple things, some more simple things, I guess, with you today. Similar to the last 2 episodes, some nice thought probing, if you will. I say simple things, but we solved world hunger 1 or 2 episodes ago, didn't we? So, maybe it's not too simple. We're changing the world here. Similarly, since we solved world hunger last week or 2 weeks ago, I thought this week we'd go ahead and solve energy too. While we're at it. Uh, so we're gonna talk about nuclear fusion, as it says in the title of this episode. Unless I decided to go and change the title, I don't know what's gonna happen. Also, I just woke up a few minutes ago. I woke up a bit late, and for some reason, my voice sounds like I'm sick. I'm not sick. At least I hope not. Anyways, last week we curled the world to hunger. This week we're curing energy, fixing energy. So in technology, we're rapidly evolving. Don't know if you guys knew that or not, but we're on like 20th gear for technological advancements. Our biggest limiting factor for like technology right now, if you look at computer chips, if you look at the biomedical field of engineering, if you look at other fields of engineering, electric cars, electric planes, these fun things and nanobots that are going to be going into your body at some point one day, hopefully, solving all of our global warming problems with a bunch of nanobots that we can just shoot into the atmosphere and have them deal with it. Yeah, we're going pretty quick into technology. And our biggest limiting factor, the reason we can't go faster, the reason we can't make better things, biggest limiting factor, or since I have a chemistry test this week, limiting reactant for our innovations in energy. Like energy is our limiting factor. We just don't have the ability to compress energy enough. We don't have the ability to make it dense enough. We don't have the ability to make it small enough while holding enough charge. Energy is a problem. So there's like batteries, fossil fuels, and that type of energy. ATP, mitochondria is doing good work. But yeah, energy that is powerful and preferably won't obliterate our atmosphere or planet. That's really tough to come by these days. And although we're doing really well with our 5 nanometer transistors, making sure that we can power that. I spoke on it a few episodes ago, way more than a few episodes ago at this point. But when I talked about linear algebra, I did not talk about linear algebra. When I talked about solid state batteries and lithium ion batteries, linear, Jesus. I don't like lithium ion batteries, but that's what we use right now, and they suck. So yeah, energy, batteries. This is the reason you don't see electric planes. Energy is the reason you get mad at your phone for dying too quickly. Energy is the reason that we aren't taking over the galaxy right now, looking for aliens so that after we meet them, we can fight them and see who's stronger, because humanity likes to say, my PP is bigger than yours. That right there is a summation of all of human history. Moral of the story, we need to figure out energy. It's one of humanity's biggest technological issues at the moment. And so there's nuclear fission, which is, we use that. You guys have heard of nuclear reactors. They're pretty big, and some people think nuclear reactors are putting a lot of pollution in the atmosphere. Not exactly into the atmosphere. All of the smoke that comes out of the big ol' tube thing that you see in nuclear reactors, it's actually like water vapor, if I'm not wrong. Does the nuclear fission or the nuclear reactors have environmental impacts? Yeah, so the uranium needs to get stored somewhere, and we kind of just like dig them up and put them in the ground, and that doesn't always work out too well. But, anyways, nuclear fission, our boy Albert Einstein, he talked about those. Now we have a bunch of metal cylinders around the world that could end us. Yeah, we love our nuclear fission, gave us our nuclear bombs, but hey, at least we, or more accurately, Albert Einstein, figured it out. What a guy. Cheeky young lad, that one. Um, Anyways, yeah, nuclear fission is the splitting of an atom's nucleus, either spontaneously or through impact. Nuclear bombs use a uranium-235 isotope. This isotope wasn't the most stable, and so making it fracture or split was possible. And there's a chain reaction of it splitting, and then things happen, and well, we all know how that story ended. Hopefully ended, at least, because if the story starts getting written again, we're all screwed. Anyways, other than nuclear fission, which is the splitting of an atom, nuclear fusion is putting them together. So nuclear fusion is something that we see in our star, Mr. Sun, as he's formally known. The sun makes atoms really, really hot, like really hot. I mean, I don't know if you've ever been to the sun before, but it's pretty hot over there. Then those atoms that get really hot, they get really, really fast, because that's how energy works. You heat something up, it starts vibrating quicker, it starts moving a lot quicker. And due to the fairly large mass of a star, or Mr. Sun in this case, he's a pretty big dude. No fat shaming here, but pretty big dude. The pressure and the heat force the original single electron hydrogen atoms into helium atoms. And then those helium atoms become beryllium atoms. The force and the pressure and the heat, it causes them to fuse together and like force themselves together, which is really, really hard to do. Again, a sun needs to do it because a sun is extremely big. A sun is extremely hot. A star needs to do it. A sun is extremely big. A star is extremely hot. And a star has, because of how big it is, an extraordinary amount of pressure going on in there. So if you go to the middle of the earth, you're going to become probably like the size of a marble. You'd get squeezed pretty quickly. Now, if you went to the middle of the sun, you would probably just like disintegrate. I mean, it'd be bad. Anyways, yeah, so that's what happens. The helium becomes beryllium, and that this process goes on in the sun as it goes until the element that gets fused becomes iron, or Fe, on the periodic table, in which the sun makes a nuclear bomb look like a pebble being dropped, not thrown, but dropped into a puddle. When stars hit the iron stage of nuclear fusion, they explode quite large. What's our biggest nuclear bomb that we've blown up on Earth? Like the SARS or something? Oh, hey, COVID is SARS. Look at that. Coincidence? Question mark. Anyways, I think I don't remember what the scale was for explosions, but it was pretty big. The sun, when it explodes, inhales the entire solar system, and other stars, when they explode, create black holes or supernovas. So, nuclear bombs have nothing on what happens when nuclear fusion gets a little bit too problematic. But anyways, when the sun is forcing these atoms together, the heat and the pressure that forces them together, when they get like forced together, an extreme amount of energy is released from it. As you know, the sun releases quite a lot of energy in the form of heat. It comes to the earth, and it makes it so that we don't have to wear blankets 100% of the time. It's a lot of energy coming from that sun. It's also the reason you're alive, because it, fuels plants, and plants is the reason that anything can eat. But a lot of energy is released from it. So over here on Earth, we want to harness that fusion energy. We want to take a star and we want to bottle it up and we want to use it, okay? And so if we can do that, it basically means infinite energy. Hitting the iron probably won't happen here on Earth because that's too hard. But instead of using the sun's rays for energy, through solar panels and such, we want to ultimately use the sun's method of energy, fusion. At least that would be the goal. We would like to do that. There might be some problems with that, which we'll get to in a second. So currently we have about 2 ways, or 2 reactors to do what the sun does right now on Earth, or at least we're experimenting with two methods. And the first one is magnetic confinement reactors. So these reactors use a magnetic field to squeeze a plasma, which is the fourth state of matter. Put simply, it's something in an unfathomably hot state. The fifth state of matter is Bose-Einstein condensate, and that is something that is unfathomably cold. Bose-Einstein condensate is probably going to be a little bit harder to come by than a plasma. You'll find plasma in the universe. Anyway, yeah, not many people know about Bose-Einstein condensate, but a lot of people will sit in their 8th grade science class, push their glasses up and say, actually, there's 4 states of matter. But, I'm going to say to you now, actually, there's 5. Eat it. There might be more. Some people will just classify them as different, whatever. After squeezing that plasma, in our magnetic confinement reactor, we hit it with some electric current, and inside of a yummy donut-shaped chamber, the reactions take place. There is a reactor in France that uses this method called the International Thermonuclear Experimental Reactor, or ITER, and it uses superconducting electromagnets that are cooled by liquid helium, which is colder than our fun guy liquid nitrogen. This liquid helium is negative 269 degrees Celsius, and absolute zero is at negative 273 degrees Celsius. That's only about, 4? Yeah, that's a 4-degree difference. So it's almost absolute zero. And then the plasma that the electromagnets heat up, that's about 150 million degrees Celsius. Yeah, that's a big number. Recall when I said plasma is unfathomably hot. Yeah. So think about your shower when you accidentally go a smidge too hot and multiply that discomfort by a factor of about 3.5. That's plasma. Also, that is not scientifically accurate. Anyways, yeah, so those two temperatures create some of the largest temperature gradients in the known universe, like the difference between negative 269 and 150 million. Yeah, it's pretty fun. It's a tad bit of a greater gradient than the feeling of trying to get out of bed in the winter when the heat isn't on. Never fun at all. But yeah, that's our first reactor, or reactor type. We have, there's like other people that have different versions of that type of reactor. And then the other reactor is the inertial confinement reactor. So here we use pulses from superpowered lasers to shoot the surface of a pellet of fuel, causing it to implode that will briefly make the fuel hot and dense enough to fuse. We use a laser from the National Ignition Facility in the United States to run some of these experiments. It's pretty cool. But yeah, so currently getting into the problems of nuclear fusion, first of all, these are experiments. I don't know like how much they've succeeded in actually like fusing things and creating that energy. But one thing is like it costs quite a lot more to make these things happen than it does the energy that we get out of it. It's not equivalent in any way, shape, or form. It's like really far into the red. Like you're just like, think of student debt, but times 20. I know that's really hard to imagine, but like, yeah, doing these experiments are not, they're not making us a lot of money at the moment. Granted, they could, right? So it's an investment thing, but hopefully, one day we'll get there. But, the cool parts about nuclear fusion is that it's renewable, right? So, like wind energy, water energy, or like hydro dams and stuff, or the solar energy that we use, renewable. And if we can make it happen, we can get the helium-2 isotope from the big lake called the ocean. So that's one of the isotopes we need to fuse together. And then we need to get a helium-3 isotope from the moon. Yep, we can mine it from the moon. So helium-3 is not an isotope that's found on Earth very much, if at all. The other one we could have used is like this helium, I forgot the name of it, but it's also some sort of helium-3 thing. But that one's like basically extremely hard to find unless you're inside of the effing sun. So helium-3, we can find that one on the moon, and building a moon base, that would be cool. So yeah, that's the cool part about nuclear fusion. We have those ingredients within our Earth system. Environmentally speaking, if these reactors were to fail, assuming we could make it happen. If a nuclear reactor fails, we get Chernobyl, we get some other fun, great, incredible things going on. They explode and kill quite a few people, and they're nuclear, so the radiation kills even more people. Nuclear reactors are extremely safe, trust me. Anyway, and also the amount of like bad things that happen in nuclear reactors is immense. Like they cut so many corners, it's horrible. Anyways, environmentally speaking, yeah, if these reactors were to fail, nuclear fusion reactors, assuming that we could make the nuclear fusion happen, the plasma would dissipate and we'd be sad that we failed, and then we'd try again. Put simply, it's not a bomb. Like, if things go wrong, we're fine. We'll be okay. We'll just be sad that it went wrong. But there's a chance that some of it can dissipate into water. It's possible, but it'd be in such little amounts that it would not be a significant problem. It would be trivial, as they would say in statistics. So yeah, our biggest issue right now with nuclear fusion is that it costs a lot of money, and we don't know if we can actually do it. Putting the sun on Earth is a little bit tough, unfortunately. So yeah, that's a little bit of our issues with nuclear fusion. But if we can do it, we've solved energy. First, we solved world hunger. Now we're solving world energy, dude. This is a seriously funny podcast here, dude. This is why we listen to this podcast, okay? Share a podcast with your friends. We're solving world problems here. The next thing I have with a few minutes left here is this weird thing. So as you guys know, as I spoke about, 2 episodes ago, I think me and morality, we don't really get along. I don't really talk to morality very much. Philosophy, ethics, I don't do that stuff very much. That's not my forte, if you will. What you ought and what you not ought, that stuff's too complicated for me. But recently, I've been thinking about this weird sense of responsibility, especially after the COVID-19 vaccine episodes a few episodes ago, which hasn't been performing the greatest. I was really proud of that episode. So much research went into it. I wonder if sleep's gonna have the same thing. I'm probably gonna, like, when I finish the sleep research, it'll probably be about like 24 to 36 hours in all of research, and it'll get like 2 it'll be great. Anyways, and half of it I do for fun, so it's okay. But yeah, after the COVID-19 vaccine episode, I've been wondering, do I have a responsibility to uphold health and like combat misinformation? Like the research I've done on psychology, psychiatry, and that I'm doing on sleep, do I have a responsibility to make sure people are doing healthy things? Should I be going out of my way to make sure, like, hey, are you sleeping enough? You really should do that, because if you don't, spoiler alert, but we'll see what happens if you don't sleep enough in a few episodes here. Other than, and like psychology, psychiatry, like, hey, what do you do? Like, are you emotionally suppressing yourself? Like, why don't you cry about it when you fail an exam? Are you cool and emotionally detached, such as myself, or do you just suppress your emotions or go like drink or do drugs to get out of it? And here's why, like, here's what happens if you do those things, and I can't recommend those things. Along with that, so like, for example, there's a baby shower for one of my I guess they'd be cousin's wife, and they're in Tennessee, and my parents want to go because they have a pretty solid relationship, but I can't, I'm not going to go, and B, I can't encourage them to go. I can't say like, yeah, go for it. It's good. Everyone's lonely. You should go see your family or whatever. But like, I don't think I can do that. If you have the ability to stay home, you should stay home. After I've done the research on the COVID thing, I feel like some part of me has to be like, hey, if you don't have to go outside, don't go outside. These numbers are a problem, and you can't just like go have fun. Like, I know you want to feel better, but like FaceTime and technology is really cool. Like, try your best to hang on so that we can get a handle over this. And just not encouraging people to travel at all, making sure people stay inside. Also encouraging people to wear 2 masks. I'm talking to people like, hey, are you going out? And like, I go out of my way to ask them, like, are you wearing a mask? And they're like, yeah. Are you wearing 2 masks? Actually, Dr. Anthony Fauci says you should be wearing 2 masks now. You should do that. It would help you and everyone else out as well. Like, go for and do that. But, and again, telling people to make sure they sleep, like, and urging people to get like professional help mentally, right? So like at one point in my life I could be like, oh, I've read a bunch of books on psychology, psychiatry, I've done a bunch of research on them, I've read so many papers, and so like this is what a bunch of papers say, like, here, you can take this and do with it what you want to. But nowadays I feel like maybe it's just getting older and maturity, I don't know if you know, but like, do I have a responsibility with my information and knowledge, and the fact that I'm not, professional or licensed, or an expert in any of these things? I'm simply proficient in these things, to uphold people and to encourage people to go seek out the professional help, and make sure they get assistance in these things. Do I have a responsibility to like combat misinformation as well? Like, if someone in if someone in my science technology society class says that that says something wrong, do I have the responsibility to correct them, or is it something I, quote, should do, or something I could do? Like, is it something I should or something I could? Something inside of me says that I should. Again, I don't think about morality ever, but as someone who's educated, do I have this responsibility? There maybe it's just like a part of my ego that's just wants to, push my glasses up and say, look at how much I know, watch me correct you, haha, idiot. But like, I don't think that's the case. Maybe it is, but does that change the fact of whether or not I should or shouldn't? No idea. Some questions come into my mind that I, as a robot, just cannot answer. So it's a really perplexing situation. I think it helps people in general overall, if we're going to go through a utilitarian method of figuring this out, in which it helps people, for me to help people. But yeah, I guess, the overall question is, should I inform people or should I convince people? Like, to one extent, I could just be like, oh yeah, here's information, here's research, and here's the objective truth, to the extent of our knowledge at the moment. Or should I like go out of my way to say like, hey, these bad things are really going to happen if you don't do this. Please actually legitimately do this. Wear 2 masks. I'm not saying it because research says, oh, it'd be good. I'm saying it because you should do it. Like, as a human being, it's your responsibility to make sure more of us don't effing die. Well, maybe not your responsibility, but it's something you could do that would be cool, and I would appreciate it, and I think a lot of other people would appreciate it if you did these things, and your own health might appreciate it if you did these things. And so, it's been something I've been thinking about a lot. And so, yeah, I did have one more topic here, and this was it was going to be a little bit on school. 18 credit hours is really tough. That's what I've learned. College needs to effing take a breath. But I have found that I need to study less in subjects like math, chemistry, and partly because linear algebra makes sense, and because I've taken a chem class in my life. But last semester, I would always look up my homework questions online, so I'm going to give you some tips here for college right here, something I learned. This semester, I've actually kind of just done my homework, only looking things up if absolutely necessary. That means whether it be on Google or my notes. I realized that I can use homework as my active recall, and not just use my time and just not use my time studying, so I can just do the homework rather than have to study harder, because the homework is just part of the studying. So I really recommend that for classes where remembering stuff matters, or arithmetic classes especially. Don't look at your notes or the internet, parentheses, except for calculators maybe, because I'm too lazy to get my calculator out. I usually just use the Google search and parentheses. I don't know why I said parentheses when I'm like reading my show notes, my bad. But yeah, so and then do your homework without the notes or without the Google. Again, if you absolutely don't know it, then you obviously have to look. But it's probably better to figure out that you don't know how to do the subject during the homework than cheating on the homework, thinking you understand how the homework like answers got to the answer, how the Chegg masters got there. Be like, oh yeah, I get that. That makes sense. And then when you get to the test, you realize you don't know anything. Yeah, I've been there. It's not pretty. But yeah, so a tip for college: don't cheat on your homework. Just do your homework. It'll probably save you more time than you think it will cost you. So just, if you do your homework, it's part of your studying. You can cut down on the like studying time for, exams, because you'll generally know things. As well as that, maybe just go do homeworks again rather than for arithmetic classes especially, so chemistry, physics, math, electrical computer engineering, one of my classes. You go do homework questions and see if you're getting those right, rather than just oh, this means this. Your memories are probably fine. And again, arithmetic classes, like scientific classes, they're going to be a lot more math based than they're going to be theory based. Physics, chemistry, they're going to have some terms and some theory that you have to understand. But when you get into harder parts of science, it's the math that gets you, because you have to understand the theory to do the math. And so if you can do the math, you can probably get the theory. Theories come from math. Anyways, that's really long-winded and complicated. But yeah, thank you for listening to this episode of Seriously Funny. Hopefully I did well on my exams. And if I didn't, maybe I'll make another episode on detachment just to make me feel better about myself. That's a joke. I'll do the best that I can. I hope that you do the best that you can. I will see you next week, probably with another inane episode, because sleep has a little bit more to go. So I'm going to probably, I have exams this week, so I'm going to be like putting effort into exams, so I won't have time to study that much. And then when I get to the weekend, I have to write another different show note already, so that, because like researching sleep is going to take another 2 days, probably it'll take quite a few hours. So that it'll probably be the 40th episode. But yeah, probably with another inane episode next week. I think I'll space out my longer episodes more often. And the COVID episode was just a few episodes ago. I think I need to make the longer episodes go a lot, space them out more, maybe 10, 15, every 10, 15, I'll do it. But yeah, the amount of time it takes to research these things versus the amount of times it takes schoolwork is just, it's not a great ratio. Granted, I do like doing the research better, so maybe I'll just say F school and do the research sometimes, who knows. But yeah, we'll see. Maybe we'll just make an episode on how to do research. Yeah, anyways, peace.